Hello and welcome to the first session of the extra credit question of Mr. Leopold's AP Calculus. Today I will be explaining the position of a particle moving along the x-axis. The function given is x of t equals cosine of pi t squared in the domain that t is between 0 and 3. The first thing that it asks to do is give the particle's velocity as a function of t. The particle's velocity is also equal to the first derivative. So, to find the velocity, you would simply take the first derivative of the main function. To do that, you would use chain rule. So, you would do cosine of u, and u would be pi t squared. That's y would equal that. So the derivative of that would be negative sine of u, and the derivative of u would be 2 pi t. So then you would simply multiply these together and get negative 2 pi t sine of u, and you would substitute pi t squared for u to get an answer of negative 2 pi t times the sine of pi t squared. And that's what the particle's velocity would be as a function of t. Now, to find the acceleration, you would simply take the derivative of negative 2 pi t, or the velocity function right here. So you would have to use product rule. So it would be negative 2 pi t times the derivative of sine pi t squared, which you would use chain rule again and get 2 pi t times cosine of pi t squared. You would then add that to the derivative of the first function, which would be negative 2 pi times the cosine of, times sine of pi t squared. You would get a final answer of negative 4 pi squared t squared times cosine of pi t squared minus 2 pi times sine of pi t squared. And that's what the particle's acceleration as a function of t would look like. Now, the third question asks, for what values of t is the particle moving to the right? That is simple, because when it's moving to the right, the first derivative would be positive. So you would use the first derivative, which is negative 2 pi t times the sine of pi t squared. Now, to find the critical points, you would set this equal to 0. And then from there, you can use the first derivative test to find where it's positive and negative. So you want to find where the inside would equal 0. Now the sign of any whole number pi is always equal to 0. So between 0 and 3, there's critical points at 0, plus or minus 1, plus or minus root 2, plus or minus root 3, 2, plus or minus root 5, plus or minus root 6, and plus or minus root 7, plus or minus root 8, or 3. Now, these values of t would all give you whole number pi's for sine, and that would cause the whole function to be equal to 0. Now, all all the critical points have to be positive because none of the negative ones are in our domain of 0 and 3. So you'll set up a table of all the intervals. I'll start over on this line. 5 to root 6 to root 7, root 7 to root 8, root 8 to root 9. Now, you would choose an x value between those two numbers, and you would plug that into what the derivative value would be to get whether it is positive or negative. And if it's positive, it means the particle is moving to the right. So for this one, I'll choose 0.5 and plug it into the derivative and solve from there. And this will give you a negative value. And keep going on down the list. I'll use 1.1, and this will give you a positive value. I'll use 1.5 here, and that'll give you a negative value. 1.9 will give you a positive value. 2.1 will give you a negative value. 2.3 will give you a positive value. 2.5 will give you a negative value. Sorry, can't see that. 2.5 will give you a negative value. 2.7 will give you a positive value, and 2.9 will give you a negative value. So what this shows is where the particle is moving to the right, where the first derivative is positive. So it's moving to the right on the intervals from 1 to root 2, root 3 to 2, root 5 to root 6, and root 7 to root 8. That's when t equals all of these. You'll get a positive first derivative, and the particle will be moving to the right. Now, the last question is find the acceleration at the first instant when the particle returns to its starting point. So you would use the second derivative, where you would use so you would use the second derivative, which is negative 4 pi squared t squared times the cosine of pi t squared minus 2 pi times the sine of pi t squared. Now, it'll return, it starts at 1, which is given in the velocity function, as at 0. The cosine of 0 would be 1. So we're looking for the point where it returns to 1 in the second derivative. And the first point that it returns is at root 2, because plugged into t squared, it'll give the cosine of 2 pi, which is also equal to 1. So you evaluate at root 2, and you should get an answer of acceleration is equal to negative 8 pi squared meters per second squared. And that's your final answer. Thank you.